if we could kind of go behind the scenes, if we could, we can't, but we'd like to. And we could go behind the scenes to labs all over the world like yours at Penn that holds promise. What can you tell people listening to this show today? What's happening right now that would bring them hope? What right now in those labs are kind of the bright light, a possible cure or some new medication in the future that might really benefit those suffering from MACD?
Well, first, let me assure your audience that there is research occurring all over the world to determine how MACD begins, as well as new therapies to slow its progression. In fact, amazing research advances have been made since the first therapy for the wet form of MACD was developed in the 1980s. This initial therapy in the 80s utilized a laser to destroy abnormal MACD blood vessels. Unfortunately, it also destroyed normal blood vessels, leading to loss of vision. So around the year 2000, a new type of laser was invented that was directed at a dye while it passed through the abnormal blood vessels of the MACD lesion. The dye was given to the patient by venipuncture, but unfortunately, while the damage to normal blood vessels was limited compared to the laser of the 1980s, vision was not improved with the laser dye combination. Therefore, the limitations for both laser treatments stimulated the development of a new drug called anti-VEGF in 2006. This drug was shown to improve vision and was a major breakthrough. But this drug has limitations that include patient variability with respect to dose and treatment periods, and the high frequency of atrophy which follows long-term injections. So to decrease the frequency of injections and make the injections more comfortable for the patient, there has been a lot of research in finding new formulations to determine if the number of injections can be reduced on an annual basis. Initial results are promising for reducing the number of injections by almost 75%. There are new injectables that are currently in phase 2, which are highly promising. There are also a few clinical trials being directed at the complement proteins. Complement is a pathway which consists of over 50 proteins. For 2 decades now, research has implicated the complement pathway in MACD. One ongoing trial inhibiting complement is with a drug called APPLE-2. Phase 2 trials of APPLE-2 have shown a reduction in the growth of geographic atrophy, and this drug has now moved into a phase 3 trial with a larger group of individuals.
So the exciting news, we have research that indicates we may be able to reduce the number of injections up to 75% perhaps.
Yes.
And we have some new complementary pathways, proteins, that could also have a significant development in a drug called APL2. So there is a lot of hope out there.